linear equations. This is a method to solve differential equations. Now the most distinguishing factor of this type of equation is that the coefficient, if it is a square, then dy by dx is also to the power square. Similarly, if it in the one with the single power also has single power in dy by dx, and so on and so on. Now to solve this equation, we will suppose the values of d square y by dx square, and this is supposed to be d into d minus 1, and dy by dx is supposed to be d. Where there is no dy by dx, we will not suppose anything. Now another thing which we have to understand is that we cannot solve this equation simply by x raised to the power 4. So we will have to substitute something else in place of x to the power 4. So for simple x, I'll say that x is equals to e to the power z, and z is equals to log of x. So x to the power 4 is equals to e to the power 4z. Now I'll call this equation 1. So by applying the rules which I have stated over here, equation 1 becomes d into d minus 1 into y minus 2 dy minus 4y is equals to e to the power 4z. If we expand this equation, we can get something like this: d square minus 3d minus 4 into y is equals to e to the power 4z. Now for the complementary function, which I'll call yc, I'll let x is equals to k. K square minus 3k minus 4 is equals to 0, and by factorizing I get two factors: k is equals to minus 1 and k is equals to 4. So my yc is equals to c1 e to the power minus z plus c2 e to the power 4z. Now for my particular integral, or yp, I'll simply take the original equation, which was d square minus 3d minus 4, and place it in the denominator and multiply it by e to the power 4z. Now since there is an exponential function, I'll just substitute d by 4. If I substitute d by 4, 16 minus 12 minus 4 equals to 0, and this is not possible. This equals to infinity, so there is no solution over there. What I'll do is I'll derive this equation, and I get 2d minus 3. Again this remain, and I'll multiply z in the numerator. Now again I'll substitute 4, because 4 is the power of e exponent. So my yp becomes z upon 2 into 4 minus 3 into e to the power 4z, and it finally becomes z 1 upon 5 e to the power 4z. Now in the beginning I told you that z is equals to log of x, and e to the power 4z is equals to x raised to the power 4. So my final solution, which I have to state in terms of y is equals to yc plus yp, I get my final solution is y is equals to c1 e to the power minus z plus c2 e to the power 4z plus log of x 1 upon 5 x raised to the power 4. That's Cauchy linear equation.